Okay, salam sejahtera. So untuk slot ini kita akan bincangkan tentang masih sama 10.1 extremum problem. Tetapi untuk bahagian 2 iaitu optimization problems. So kita masih akan ulang proses yang ada pada bahagian pertama, okay, iaitu dalam extremum problem. Bahagian pertama iaitu macam mana nak cari critical number. Proses yang sama kita akan guna iaitu equation. Maksudnya variable dia mesti kena diasingkan. Yang kedua, first derivative, second derivative. Yang ketiga, kita perlu buat apa? Cari critical number dia. Akhirnya, kita akan guna second derivative test untuk menjawab soalan ni. Tak apa, saya just bagi tahu draft. Sekarang kita tengok kita punya slide dan kita akan tengok macam mana nak menjawab soalan optimization problem ini. So, kalau kita tengok sini dia ada dia punya step. So, mohon cuba fahamkan dan ikut.
For the problem, optimization problems. The following are the steps for solving optimum problems. Step number 1. Identify the variable to be maximized or minimized. Let's say the variable y. Express variable y into a single variable function, or we can say y as a subject. And for the right hand side, must be a single variable as well. Step number 3. Solve for f prime x equals to 0. Or we can say, identify the critical numbers or the problems. Step number 4, verify the solution for f prime x equals to 0 by the second derivative test. Number 5, get the optimum value of y equals to fx if it is required. Here we have the example. You have been asked to design a 1 liter oil can shaped as a cylinder. What dimension will be used the least material? So in order to fill up 1 liter oil can, meaning that we have to design the situation or the cylinder. So in here, the dimension will be used would be the area. So from the information, identify the variable to be maximized or minimized. So in here, the area is the variable. So let's open up the situation. We have a 2 circle and open up the body of the cylinder. So in here, we have 2 pi r multiplied with h. The area for the circle will be pi r squared. So in here we have 2 circles, so meaning that the area will be equals to 2 pi r multiplied with h. We will obtain the area of the body plus 2 pi r squared because we have to add on the 2 circles.
Okay, so sekarang ingat step yang pertama. Identify the variable to be maximized or minimized. Says variable y. So kalau kita tengok sini, di sini tak ada xy tetapi kita ada a. Nampak? A, satu variable. Kemudian kita ada R, 2 variable. Kita ada H, 3 variable. So macam mana kita nak buat supaya dia tinggal satu variable sahaja di kiri, satu variable sahaja di kanan. Sama ada R sahaja semua atau H sahaja semua. So itu adalah langkah pertama. Kemudian langkah kedua, dia kata express Y into a single variable function. Okay, sebagai contohlah, A equals to, di sini saya tak pasti apa, tapi yang penting semua in terms of R. So, mari kita tengok fokus kita yang pertama.
Next, from the information given, 1 liter oil can refers to a volume. So in here, the volume is equals to 1000 ml or 1 liter. So the formula for volume would be V is equals to pi R square H. So from here, we are going to have a single variable, meaning that express A in terms of R or H. So by using the information given for the volume, so we will have 1000 equals to pi R square H. In order to express the situation in a single variable for the right hand side, so now let's H is equals to 1000 over pi R square.
So saya guna apa? Saya guna info yang saya ada, 1 liter ni volume kan. So saya dapatkan H equals to 1000 over pi R squared. Mana dia kalau saya substitute H ke dalam sini, sebelah kiri hanya A sahaja, sebelah kanan semua hanya R sahaja.
So kindly substitute the H into the situation and we will obtain equation. So A is equals to 2 pi R bracket 1000 over pi R squared plus 2 pi R squared. Simplify and rearrange. So we will have 2000 over R plus 2 pi R squared. So now we will have step number 1 and step number 2. Express y, in this case, it become a into a single variable function, meaning that a as a subject in terms of r. Kindly modify.
Okay, so dengar step pertama dengan step yang kedua. Okay, step pertama adalah cari dia punya variable, apa dia. Step yang kedua adalah express situasi anda, satu variable di kiri, satu variable di kanan. Itu adalah step kedua. Step ketiga, apa yang kita perlu buat? Iaitu differentiate. Untuk first derivative dengan second derivative. So berdasarkan situasi ini, kita kena differentiate A respect to R.
The situation, a is equals to 2000 r to the power negative 1 plus 2 pi r squared. Next, let's proceed for the third step. Solve for f prime x equals to 0. So in here, we are going to find the a prime. Or we can say dA dr. So equals to 4 pi r minus 2000 r to the power negative 2. Rearrange the situation. And also find the second derivative. And we will have second derivative equals to 4 pi plus 4000 r to the power of 3. Rewrite the situation. 4 pi plus 4000 over r cubed.
So perasan tak situasi di sini? Dia macam ulang kan tentang extreme problem. Kita ada bahagian pertama yang ada 3 step, ingat tak? Yang pertama, y equals to sesuatu x. So di sinilah A sama dengan R. Nampak? A sama dengan R. Kemudian yang kedua adalah kita buat apa? Kita differentiate. Betul? First derivative, second derivative. Kemudian langkah yang ketiga, step ketiga buat apa? Kita cari critical number.
Next, find the critical value of the problems. dA dr equals to 0. Kindly substitute the situation. So 0 will be equals to 4 pi r minus 2000 over r squared. Rearrange the situation. We have 2000 over r squared equals to 4 pi r. So we will have 2000 equals to 4 pi r cubed. Rearrange the situation. R is equals to 2000 over 4 pi. We have a cube root. So finally, r is equals to cube root of 500 over pi. So that we have a critical value or a problems.
Okay, so nampak ini adalah step yang ketiga, iaitu cari masalah kita. Okay, dy dx atau dA dr equals to 0. Akhirnya saya dah dapat dah saya punya masalah, iaitu saya punya R. Seterusnya, saya nak cari apa? Saya perlu test. Ingat tak? Second derivative test. Saya perlu test supaya saya boleh dapat least material, maksudnya minimum.
Step number 4, verify the solution by using the second derivative test, meaning that substitute the r into the second derivative. So we will have second derivative equals to 4 pi plus 4000 over r cubed. So in here we will have 500 over pi if we simplify the situation and rearrange the situation. So we will have second derivative equals to 4 pi plus we will have 4000 pi over 500. So meaning that in here we will have 4 pi plus 8 pi. And second derivative equals to 12 pi where we have greater than 0.
So ingat, kalau greater than 0 untuk second derivative bermaksudnya minimum.
If the situation is greater than 0, meaning that r equals to cube root of 500 over pi is a minimum value. For step number 5, get the optimum value of y equals to fx if it is required. So in here, what dimension will be used? The least material.
So dimension least material. Maksudnya kita nak apa? Kita nak dia punya area. Faham? Kita nak dia punya area. So kita perlu gantikan kita punya R ini ke dalam formula kita yang ada area. So yang ini. Then kita dapatlah berapa material yang kita perlu untuk buat silinder ini.
In here, we need to substitute the value r into the function where a is equals to 2 pi r squared plus 2000 over r. So if we substitute the value, r is equals to cube root of 500 over pi, and we will obtain A equals to 553.6 cm square.
Okay, so ini adalah contohnya lah. So kalau you tengok semula, apa step dia? Okay, iaitu bahagian pertama. Ingat tak step dia? Equation itu yang pertama. Yang kedua adalah differentiate. First derivative, second derivative. Kemudian cari masalah. Kemudian uji masalah dia. So di sini adalah second derivative test sebenarnya. Dan akhirnya menjawab soalan. Okay, so kita masih ada lagi contoh yang kedua. So cuba baca soalan lah dan lukis keadaan itu.
A rectangle is to be inscribed in a semicircle of radius 2. So on the right hand side, we have the xy axis. Here we have a semicircle of radius 2. Next, what we have to do is to inscribe a rectangle into the semicircle. Then we have to add on the information where we have y and we have x as a horizontal line. Next, given that we have a radius, which is 2. What is the largest area the rectangle can have? And what are their dimensions? So in here, we can see the variable that we want to discuss is the area. So kindly have the formula A equals to 2xy. Because here we have another x. So x plus x, we will have 2x multiplied with the vertical or the height, which is y. So we have A is equals to 2x multiplied with y. So from here, we notice that this is a...
Okay, cuba fahamkan ya, a rectangle is inscribed, dimasukkan ke dalam semicircle. So kita ada semicircle, boleh? Kemudian dia kata radius dia 2, bermaksudnya dari sini hingga ke sini 2. So what is the largest area? So keyword area. So area of a rectangle. So katakan kita let dia x, ini let dia y. Faham? Variable. So what are their dimension? So yang pertama kena ingat, kita mesti kena ada equation. Kemudian yang kedua, kita mesti kena cuba buatlah sesuatu supaya kita kiri ada satu variable saja, kanan pun satu variable je. Jangan ada x, y. Sama ada x saja atau y saja. So kita boleh dapat idea apa? Kita nampak ya, sini adalah 2 kan? Okay? Sebab kita nampak Pythagoras theorem. Dan kita cuba kaitkan.
2. So we have another equation, which is x squared plus y squared equals to 4. Here we have the situation. Step 1, identify the variable to be maximized or minimized. In here, area will be our focus. Second step, express a in a single variable, meaning that a on the left and only x or y on the right hand side. So make use of the green color formula. Kindly express in terms of x. So y is equals to 4 minus x squared. We have a square root. So y in terms of x. Substitute the y into the area and we will have a equals to 2x multiplied with 4 minus x squared, where we have square root. The second step, express a in terms of x. Third step, we have to differentiate, or we can say find the first derivative and also the second derivative. By using the product rule, so what we have is a equals to 2x bracket 4 minus x squared power of 1 over 2. Let this one as a u and this one as a v.
Okay, so ini differentiation product rule. Ingat tak? Salin yang belakang, differentiate depan. Salin yang depan, differentiate belakang. So ingat tricks dengan tips tu.
A prime, or we can say dA dx. So dA dx will be equals to product rule. So 4 minus x squared power 1 over 2 multiply with u prime. So in here, differentiate 2x, we will have 2 plus bracket 2x multiply with v prime. So where we will have 1 over 2, 4 minus x squared to the power of negative 1 over 2. Differentiate the internal function, which is 4 minus x squared, and we will have negative 2x. dA dx is equals to 2 square root of 4 minus x squared plus, if we simplify the situation, and we multiply with this part, and we will have negative 2x squared. Here we have negative 1 over 2, so the situation will be ratio square root of 4 minus x squared. dA dx, if we equate the denominator, and we will have 2 bracket 4 minus x squared minus with 2x squared over square root of 4 minus x squared. Simplify the situation. So in here, we notice that we have 8. negative 2x squared, negative 2x squared. So finally, dA dx is equals to 8 minus 4x squared over square root of 4 minus x squared. Or dA dx is equals to 8 minus 4x squared bracket 4 minus x squared power of negative 1 over 2.
Okay, so nampak prosesnya. So bukan setakat kena ikut step. Oh, rupa-rupanya kemahiran-kemahiran dalam differentiation chapter 9 tu kena bawa ke sini juga. Okay, so sini ada product rule automatic lah. Mungkin ada quotient rule. Tapi ingat, cuba elak quotient dan buat product. So di sini kita dah buat first derivative. Sama juga kita kena buat second derivative juga.
Next, we are going to find the second derivative. Kindly refer to this part and let this one become u and then v. We have v, so 4 minus x squared bracket power of negative 1 over 2 multiply with u prime, so where we will have negative 8x plus multiply with u multiply with v prime. So in here v prime would be negative 1 over 2 bracket 4 minus x squared to the power of negative 3 over 2 multiply with the internal derivative, so we will have negative 2x. Kindly simplify the situation. So second derivative will be equals to negative 8x over square root of 4 minus x squared. Plus, if we simplify the situation, we will have x. So in here, we will have 8 minus 4x squared multiply with x over 4 minus x squared. So here we have the second derivative. Step number 3, solve for f prime x equals to 0 or identify.
Okay, nampak second step tu differentiate okay for the first derivative dengan second derivative. So step ketiga kena buat apa? Cari critical number, masalah tu. Then step keempat kita test. Then akhirnya menjawab soalan.
Find the critical value or problems where we have to let dA dx equals to 0. So in this case, 0 is equals to 8 minus 4x squared over square root of 4 minus x squared. 8 minus 4x squared will be equals to 0. X squared is equals to 8 over 4. So x squared will be equals to 2. So x will be equals to square root of 2. X will be equals to negative square root of 2. So here we have the critical value. Kindly substitute the value of x into the second derivative. So here we will have if x is equals to square root of 2, by using the calculator, the second derivative will be equals to negative 8, where a is less than 0. So, the maximum value would be x is equals to square root of 2. If the x is equals to negative square root of 2, the second derivative will have 8, which is greater than 0, and it is a minimum value when x is equals to negative 1 over 2. Kindly find the dimension. If x is equals to square root of 2, y is equals to square root of 4 minus x squared. If we substitute the value, y we will have square root of 2 as well. So the maximum value would be x equals to square root of 2 and y is also equals to square root of 2. So as we all know, the area is equals to 2xy. So in here, a is equals to 2 multiplied with square root of 2 for the value y and value x. So finally, the value of a is 4 unit square.
So kalau tengok sini kita ada first derivative, second derivative. Kemudian kita kena cari masalah lah. Masalah kita dah jumpa. So kita kena test. So ini minimum, ini maximum. Baca soalan kata apa? What is the largest area? Maksudnya maximum. So that's why kita ambil lah yang ini, X. Boleh? So kita menjawab soalan, dia nak cari dimension dia. So kita substitute dan akhirnya kita dapatlah jawapan kita. So ini adalah contoh yang kedua lah, optimization problem. So ini adalah soalan yang ketiga yang saya nak bincang. Okay, so kita tengok.
An open top box is to be made by cutting the small congruent square from the corner of a 12 cm by 12 cm sheet of tin and bending up the side. How large should the square cut from the corner to be make the volume of the box maximum? So in here, step number 1, identify the variable to be maximized and minimized. So in here, the volume is the key or the variable. So now kindly refers to the box. So in here, we will have 12 minus 2x. Same goes to this part, we will have 12 minus 2x. Because, as we all know, here we will have 12 minus with the x So we will have 12 minus 2x. So in order to find the volume for the box, we will have V is equals to 12 minus 2x multiplied with 12 minus 2x multiplied with the height, which is x. So in here, V will be equals to 12 minus 2x square multiplied with x. Next, what we have to do is to expand the situation. V will be equals to 144 minus 48x plus 4x square. Again, repeat the process. The volume will be equals to 4x cubed minus 48x square plus 144x. Second step, express y into a single variable. So as we all know.
Okay, so yang pertama mesti kena tahu kita punya variable apa. So di sini dia kata volume. Bila baca volume. So kena cuba bayanglah, kalau you lipat sisi ini, dia akan berdiri tegak kan? Then dia boleh buatlah satu kotak. Faham tak? Di sini ada sebut open top, maksudnya tak bertutup. Dia buka saja. So apa yang saya buat adalah you punya base, okay, times dengan you punya base di sini, kemudian times dengan you punya height. So dapatlah situasi ini. So ini adalah step pertama. Okay, step pertama. Step kedua, mesti make sure left hand side one variable, right hand side one variable. Step ketiga, buat apa? Iaitu differentiate situasi itu for the first derivative dengan second derivative.
No, for the left hand side we have volume. For the right hand side we only have a single term, which is a x. Next, what we have to do is to find the first derivative and the second derivative. So in here, v prime would be dv dx. So 12x squared minus 96x plus 144 for the first derivative. Next, for the second derivative, we will have 24x minus 96. Step number 4. Solve f prime x is equals to 0 in order to find the critical value or the problems. So here we have v prime equals to 0. So 12x squared minus 96x plus 144 equals to 0. Kindly simplify the situation. Factor out the 12. So we will have x squared minus 8x plus 12 equals to 0. 12 bracket x minus 6. X minus 2 equals to 0. So x will be equals to 6 and x will be equals to 2. Here we have the critical value or the problem.
Okay, so ini adalah masalah. Seterusnya kena buat apa? Kena test. Okay, kena test. So di sini kata dia nak maximum. So second derivative saya mesti less than 0. So ingat, step pertama dapat variable. Okay, siap. Step kedua, make sure kiri dengan kanan dapat satu variable. Then differentiate, first derivative, second derivative. Kemudian cari masalah, akhirnya uji dan menjawab soalan.
Problems. Next, we have to verify the situation by using the second derivative. So when x is equals to 6, v double prime will be equals to 48, where we have greater than 0. So in this case, it will become the minimum value. As for x equals to 2, v double prime 2, we will have a negative 48. So in this case, this one is considered as maximum value. So kindly refers to the questions. How large should the square cut from the corner to be made the volume of the box maximum? So in this case, maximum meaning that the value of x should be 2. So meaning that how large the square cut from the corner. So this is what we call the corner. So x multiplied with x.
Berhati-hati ya. Kita nak tanya x ini. Maksudnya kena buang berapa. Faham? Bukan menjawab soalan di sini ya.
So the area will be x squared. So as we all know, the x is 2. So area will be 2 to the power of 2. Area will be 4 unit square, or we can say 4 cm square.
So bila menjawab soalan tu kena baca betul-betul. Okay, kena baca betul-betul soalan nak apa. So ini adalah contoh yang ketiga lah. Contoh yang ketiga. Ada lagi? Kita teruskan lagi. Okay, so ini adalah contoh yang keempat untuk optimization problem.
Find the distance for a rectangle which has a maximum area, given the circumference is 80 cm. So here we have the diagram, which is a rectangular. So kindly determine the variable to be maxima and minima. So in here, area is the key. So in order to find the area, rectangle for the area, so A is equals to X and Y. Given the information, circumference is 80 cm. So meaning that we have P, the perimeter, is equals to 2x plus 2y. Step number 2, express the A in a single variable function. So meaning that A must be equals to x. So kindly substitute the value. 80 is equals to 2x plus 2y. Simplify the situation, we will have 40 is equals to x plus y. So in here, y is equals to 40 minus x. Kindly substitute the y into the area and we will have A is equals to x multiplied with 40 minus x. Or the second step, express the A into a single variable. So here we have A is equals to 40x minus x squared. Third step, find the first derivative and the second derivative. So in here, dA dx is equals to 40 minus 2x. For the second derivative will be negative 2. Next, we are going to find the critical value or the problems. So in here, dA dx must be equals to 0. So 40 minus 2x must be equals to 0. So 40 equals to 2x and x must be equals to 20. So where we have a critical value. So if x is equals to 20, y will be equals to 20 as well. Kindly substitute the value x 20 into the equation y equals to 40 minus x. So finally, we have to verify the solution. Since we have second derivative is a constant which is less than 0, meaning that it is a maximum value when x is equals to 20. So in here, we have the maximum value when x equals to 20 and y is equals to 20 and the area will be xy. So meaning that 20 multiple with 20, we have 400 cm square for the area.
So kalau baca soalan, soalan nak apa? Find the distance. Faham tak? Soalan nak distance. So jawapan saya sepatutnya saya kena cakap lah x tu 20, y tu 20. Okay? Soalan dia kata has a maximum area. Tetapi dia tak cakap dia nak cari area, dia just nak distance. So jawapan sepatutnya adalah x sama dengan 20, y sama dengan 20. So itu contoh lah untuk optimization problem. So kalau you tengok semula, dia hanya ulang proses yang sama, iaitu cari masalah, kemudian express kiri satu variable, kanan satu variable. Betul? Seterusnya kita differentiate untuk step ketiga, first derivative, second derivative. Kemudian kita uji. Okay, dah dapat critical, kita uji. Akhirnya menjawab soalan. So proses inilah optimization problem. So dia adalah sama macam yang kita tentukan extremum problem tadi. Step dia sama. So that's why mereka pada 10.1 itu. Faham? 10.1 itu. So teruskan lagi, kita ada contoh lagi. So untuk contoh macam ni, kena ingatlah, mesti kena mahir untuk buat lukisan. Bila baca ayat, lepas tu kalau boleh imagine, buatlah lukisan. So kebetulan soalan ni dia bahagilah lukisan ni. So taklah susah sangat.
We have the problems for extremum problem. A 100 meter long wire is used to shape the diagram. Show that the area is equals to 300x minus 36x squared. Find the value of x and y so that area has a maximum value. Kindly refers to the diagram. We have a perimeter long 100 meter. So kindly form the equation. So in here we have 5x plus y plus 6x plus y plus 5x equals to 100 meter long. So simplify the situation and we will have 16x plus 2y equals to 100. Kindly simplify the situation and we will have 8x plus y is equals to 50. The first equation. Second equation, we are going to find the area. So there are several parts. So number one, we have part A, part B, and part C. In order to find the area, we're going to have part A, which is, here we have 3x. Here we have 5x. And automatically, here we will have 4x because of Pythagoras theorem. So in order to find the A, we will have 1 over 2 multiplied with 3x and 4x, part A. So we will have 6x squared. For part B, we're going to repeat the same process. A and B actually is the same. So we will have 6x squared as well. For part C, we will have 6x multiplied with y, and we will have 6xy. So at the end, area will be equals to 12x squared plus 6xy. So step number 1, express the area in terms of x or y, either x or y. So now, in order to make sure we have a single variable on the right hand side, we have to make use of the first equation, which is y is equals to 50 minus 8x. Kindly substitute the situation into the area. So we will have a is equals to 12x squared plus 6x multiplied with 50 minus 8x. Expand the situation. So we will have 12x squared plus 300x minus 6 multiplied with negative 8. We will have 48x squared. Kindly simplify the situation. We will have 300x minus 36x squared. So here we have shown the situation, which is area equals to 300x minus 36x squared. Step number 1.
Okay, so kalau you tengok semula soalan tadi soalan dia sebenarnya sama je. Sama saja. Dia ulang proses yang sama, iaitu step pertama kena cari equation dia kan. Di sini dia baik hati, dia bagi you jawapan dah sebenarnya. Faham? Cuma you perlu show lah situasi itu. Kita perlu teruskan lagi. Okay, di sini nampak tak dia kata maximum. So maksudnya second derivative kita kalau boleh mesti less than 0 lah. Teruskan.
Step number 2, find the first derivative and the second derivative. So second step, a prime will be equals to dA dx. dA dx equals to 300 minus 72x. Second derivative, a double prime equals to negative 72. Step number 3, find the critical numbers or the problems. How to find the critical numbers or problems? Where we have a prime equals to 0, a prime equals to undefined. So now, a prime equals to 0, where we have 300 minus 72x equals to 0. Kindly rearrange the situation, and we will have 300 equals to 72x, and x is equals to 25 over 6, or 1 over 6. So for the situation, a prime equals to undefined, for this case, does not exist. So here we have the value of x. Next, verify the value of x so that it is a maximum value. So kindly refers to the second derivative equals to negative 72, where negative 72 is less than 0, so it is a maximum value when x is equal to 25 over 6. Question asks us to find the value of x and y so that area has a maximum. So in here, the x is equal to 25 over 6. Kindly substitute the situation where the x equals to 25 over 6 into this part. With the help of the calculator, we will obtain the value of y will be equals to 50 over 3.
So itulah situasi dia. So kalau kita tengok soalan ni pun sama, dia ulang step-step yang sama. Betul? So yang paling penting adalah permulaan dia. Macam mana nak bentuk benda ini. Itu yang mustahak. So one more example.
Here we have the example of optimization problems. The length of the side of a rectangular shape of a metal are 8 cm and 3 cm. So let's say we denoted here as 8 cm. And here we have 3 cm. A square of a side x, so meaning that here we have x and x, is cut from each corner of the sheet, and the remaining piece is folded to make an open box. Show that the volume of the box is given by volume equals to 4x cubed minus 22x squared plus 24x. So in order to find the volume, first we have to know what is the length and the width. So here we have 8 minus 2x, because here we will have x as well. Next, for this situation, we will have 3 minus 2x, and the height will be equals to x. So volume will be equals to 8 minus 2x multiplied with 3 minus 2x multiplied with x because of the height. Then expand the situation. V is equals to 24 minus 16x minus 6x plus 4x squared. Again, multiply with x. Then expand the situation. V is equals to 24x. Negative 16, negative 6, we will have negative 22x. If we multiply with x, we will have 22x squared plus 4x cubed. So finally, rearrange the situation. V is equals to 4x cubed minus 22x squared plus 24x. Shown the situation. Kindly refers to the question, and we have shown. The volume is so. B. Find the volume of X for which the volume of the box is maximum. Calculate the maximum volume. Step number 1. Express the situation in a single variable. So here we have the volume on the left and the right hand side in terms of X. Step number 2. Find the V prime and the second derivative V double prime. So in here, dV dx is equals to 12x squared minus 44x plus 24. Here we have the first derivative. For the second derivative, we will have (24x minus 44). Step number 3. Identify the critical numbers or the problems. V prime is equals to 0. V prime is equals to undefined. So in here, 12x squared minus 44x plus 24 equals to 0. V prime is equals to 0. Factor 4, and we will have 3x squared minus 11x plus 6 equals to 0. Kindly factorize the situation. We will have 3x minus 2, x minus 3. So finally, x equals to 2 over 3, x equals to 3. So this is what we call the critical numbers or the problems. Next, we have to verify the situation by using the second derivative. Kindly substitute the value x equals to 2 over 3 in the second derivative. So we will have v double prime equals to negative 28, where we have less than 0. So it is the maximum value when x is equals to 2 over 3. As for x equals to 3, if we substitute into the v double prime, and we will have v double prime equals to 28, where we have greater than 0, so it is the minimum value. So kindly refers to the question, find the value of x for which the volume of the box is maximum. So the answer will be equals to x equals to 2 over 3. Next, calculate the maximum volume. So in here, formula of volume is equals to 4x cubed minus 22x squared plus 24x. If we substitute x equals to 2 over 3, and we will have our answer, volume is equals to 200 over 27 unit cube.
Okay, saya tak nak ulang banyak sangat lah. Okay, so kalau kita tengok soalan ini, daripada real life activity kita, kita boleh tahulah, kalau kotak itu, cuba imagine kalau kita punya X adalah 2 over 3, kotak kita macam mana? Kotak kita pendek atau rendah lah, kemudian dia lebar. Kemudian kalau kita punya X adalah 3, okay, maksudnya kotak kita dia kecil sikit tetapi dia tinggi. So mana satu jenis yang maximum volume? Kita tak boleh agak-agak, kita kena guna formula ini atau chapter ini punya kemahiran untuk menentukan which one is the best. Berdasarkan you punya situasi lah. So maksudnya apa-apa pun kita nak buat keputusan, kita kena berdasarkan bukti pengiraan. Okay? So lebih kurang macam tu sajalah contoh-contoh yang saya boleh bincang untuk chapter 10.1 Optimization Problems, iaitu part 2. Okay, slide yang sebelum ni kita bincang apa? Extremum problem. So saya ulang semula untuk part 2 ini, iaitu Optimization Problem. Yang pertama, mesti kena tahu fokus soalan kita apa. Okay, iaitu tajuk kita apa. Yang kedua, kita kena make sure kita buatlah sesuatu supaya kita express situasi kita y in terms of x berdasarkan keadaan lah. Step yang ketiga adalah buat apa? Cari dia punya derivative. First derivative dengan second derivative. Kemudian cari critical number. Seterusnya step keempat kita test, iaitu second derivative test. So kalau less than 0 adalah maximum, kalau greater than 0 adalah minimum. Yang kelima adalah menjawab soalan. So Itu saja untuk slot optimization problem. Terima kasih.